All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies course, I've been creating a series of video presentations that are based on the Mozilla Developer Network Learn Web Development series. I'm coming toward the end, and I'm in the server-side programming portion, and I'm talking Express with Node.js. So far in here, I've done the overview, the Express Node introduction, the setting up the environment. We did part 1 of our 7-part tutorial, the local library website. We did part 2, creating the skeleton website. So you can see that we're about halfway through this, and we've got parts 3, 4, 5, 6, and 7 left. We're on part 3 now, using a database with Mongoose. So as mentioned, the article briefly introduces database and how to use them with Node Express apps. It then goes on to show how we can use Mongoose to provide database access for our local library website. It also explains how object schema and models are declared, field types that you can use in here, and basic validation. It also shows a few of the main ways that you can access model data. Now, one thing to realize, again, just going through this does not make you an expert. You're being introduced to a boatload of things in this particular series. My plan is in the AWD 1111 class is we will do several of these projects as a class. All right, and either we'll get a project done partway and then I'll have you finish, or we will do an entire project, which is probably the way we'll start, and then I will have you create a similar type of project on your own. All right, so with the overview here, library staff will use the local library website to store information about books and borrowers. Members will use it to browse and search for books, find out whether the book they're looking for is available, then reserve the book to be, to borrow it. In order to store and retrieve this, it says we will store this information in a database. I've already talked about CRUD with you before. Express apps, as it says, can use many databases, and there are many approaches you can use to perform CRUD. Again, CRUD is an acronym for Create, Read, Update, and Delete. For those of you who were in my AWD 1100 class last semester, our C# programming class, we did look at CRUD. And again, create was like an insert, read was like a select, update and delete were the same thing as their names that are shown. So this tutorial, as it says, provides a brief overview of some of the available options and then goes on to show in detail the mechanisms selected. So Express apps can use any database supported by Node, and some of the more popular ones are shown there. When choosing a database, as mentioned here, you should consider the same kind of things we talked about before. That is productivity, learning curve, performance, etc. And then you should add in things like ease of replication and backup. All right, it's important, maybe not so much for a project like this, but you can, as you can imagine, Amazon not only, I'm sure, has a backup strategy, but they probably back up their servers at a minimum, I would guess, maybe even every 5 minutes. When you think about the amount of the number of transactions that go on in there over and over and over again at all times. All right, while there is no single best database, almost all of the popular solutions should be more than accessible, or than acceptable, I should say, for what we're creating. There are two common approaches for interacting with a database. You can use the database's native query language, as it says, such as SQL, or you can use an object data model or an object relational model. Those two, as mentioned, represent the website's data as JavaScript objects, which are then going to be mapped to the underlying database. The best performance can be gained by using SQL or whatever query language is supported by the database. ODMs, as mentioned there, are oftentimes slower because they use different types of translation code, because what you have to do is you have to map the object to the format the database can understand. As it says, this may not use the most efficient database queries in order to do this. The benefit, though, of using one of these ORMs is that programmers can think in terms of JavaScript objects rather than in database semantical terms. All right. So using ODM, ORM often results in lower cost for development and maintenance. Unless you're very familiar with a native query language, you should strongly consider using an ODM. So, as it says there, which one should we use? There are many available, a few that are popular at this time of writing. Let's just talk about the one that we're going to use. All right, and that is Mongoose. Mongoose is, as it says, it's an object in the MongoDB. All right, the MongoDB NoSQL relational data, or I shouldn't say relational, database management system. As they say, it's a tool designed to work in an asynchronous environment. There are other ones utilized here. Another one that you may want to become familiar with is Sqlize, which, as it says, is a promise-based ORM for Node.js. Why? Because notice it supports, amongst other things, MySQL. All right. As a general rule, you should consider both the features provided and the community activity. How many times has it been downloaded? All right. How good is the documentation? How good is the user community, etc. when selecting a solution? All right. It says at the time of this writing, Mongoose is, if not the most popular, it's at least up in the group picture, so to speak. And it's a reasonable choice if you're using MongoDB for your database. Again, that's the one we're going to use. So for the local library example and the rest of this topic, we're going to use the Mongoose ODM to access our data. Notice Mongoose acts as a front end to MongoDB. MongoDB, again, is an open source NoSQL database. Rather than having tables, etc., it uses what are called documents. As it says, a collection of documents in a Mongoose database is analogous to a table of rows. So the collection of documents is like a table of rows. The big difference, though, between using something like MongoDB, a NoSQL database, and using something like MySQL, a relational database, is when you use something like MySQL, your schema, in other words, how you set up your fields, etc., must pretty much remain the same for each record in a particular table. Whereas in a NoSQL database, that's not true. All right. So, as it says, the Mongoose ODM is extremely popular in the Node community, particularly because of the document storage. It looks very much like JSON. You'll notice that when we get into it. You don't need to know MongoDB in order to use Mongoose, although parts of the Mongoose documentation are easier to understand if you're already familiar with MongoDB. We are going to talk MongoDB in the AWD 1111 class. All right. The rest of this tutorial shows you how to define and access the Mongoose schema and models for the local library website example. All right, we're doing fine right now on time. So it says before we jump in and start coding the models, it's worth taking a few minutes to think about the type of data that we're going to be storing and the relationship between these different objects. It says we need to know, or we know that we need to store information about books. And there's the books information. I'm not going to read that stuff out to you. And that we might have multiple copies available, which should make sense. You typically, if you've got books that are popular, you'd have more than one copy of the same book. We might need to store more information about the author than just the author's name. And there might be multiple authors, all right, with the same name or with similar names, just like there might be multiple authors for some books. We want to be able to sort information based on the book's title, the book's author, the genre. I mean, is it mystery? Is it science fiction, etc.? All right. And the category. When designing your models, it makes sense to have separate models for every object, a group of related information. This is where this becomes more an art than a science, because there's not an exact way of doing this that's going to be right. It can be done in different ways. All right. In this case, some obvious candidates are going to be a book object. All right. A book, models for these models are books, book instances, and authors. You might also want to use models to represent selection list options. So it says, for example, like a drop-down list of choices, rather than hard-coding the choices into the website itself. This is recommended when all the options aren't known up front or may change. A good example is a genre. Not only that, what do you do? Is it possible that you could have books that would appear on more than one genre? Could it be a fantasy book that's in the science fiction realm, for example? All right, once we've decided on our models and fields, we need to think about how or what are the relationships between them. All right, with that in mind, it says the UML, which is the Unified Modeling Language, associated diagram below, which is going to be down here. We'll look at it in just a second. It shows the models we'll define for us in boxes. We've created models for books, and that's, as it says, the generic details for a book. Book instance, status of physical copies of the book available on the system, and author. We also decided to have a model for genre so that we can create this dynamically. So we can add, update, remove, whatever with genres. We decided not to have a model for the book instance status. We will hard code the acceptable values because we don't expect these to change. Within each of the boxes, we'll see the model name, the field names and types, and the methods and their return types. So when you look in here, this is basically saying, let's make this a little smaller there, that each book should have a title, an author, a summary, an ISBN, a genre, and a URL. And you can see the different types that each one of these are. Now notice author says is of type author. That means that the author will have this information in there. So you can see that this particular object has another object as part of its features and functionality. This one does not. An author has a first name, looks like a last name, a birth date, a death date, a name, a lifespan, and a URL. All right. Now, when we look in here, the first thing in a book instance is a book, so it's going to be this stuff. All right. An imprint, a status. A status, notice, is going to be an enumerated value. An enumerated value, again, is a user-defined type of data. And a due-back date. Genre has just name and URL. You'll also notice the relationships here. 1 to 1. This means every one author can be an author of one or more books. All right, so we're assuming that if you're in here, you're already the author of at least one book, but you can be an author of multiple books. Notice the relationship is many to many. So this is a one-to-many relationship here. This is a many-to-many relationship because 0 or more books can be in the same genre, and each genre can have 0 or more books. There is also a one-to-many relationship between book and book instance. Now you'll notice this says 1 star 1, and this says 0 star. The difference is we're assuming that an author exists where a book instance may or may not exist. All right, so again, the diagram shows the relationships, and that's what I just mentioned to you. These are referred to as multiplicities. You can read that on your own. I gave you my own take on it. All right. All right, it says, as discussed in our Mongoose primer, which we're going to go to next, below, it is often better to have the field that defines the relationship in just one model. Below, we have chosen to define the relationship between book and genre and book and author in the book schema. So there's the genre part of it, and there's the author part of it. All right. The choice was somewhat arbitrary. We could have equally had the field in another schema. Again, as already mentioned to you, this is an art as much as a science. Let's put it that way. Two people can look at the same situation and decide to set up totally different types of schemas, all right, totally different types of relationships, etc., and they can both be correct. All right. The next section here provides a basic primer on how models are defined and used. As you read it, consider how we will construct each of the models in the diagram above. Let's put that, we're at 15 minutes, so let's put that into, or start that at least, in our next lecture.